Let's get into Newton's laws of motion. Oh, this is a big mess. I wish this thing would clean itself up. All right, let me push these out of the way and push this out of the way and pull that out of the way. So now, here we go. Newton's first law of motion. An object will stay at a constant velocity unless a net force acts on it. I know all of those words. These are new. Net force. Let's take a look at what a force is. A force is a push or pull. All right. Oh, push or pull. It has direction. We all know what that means. Vector. So, a push or a pull in a certain direction. So, let's take a look at that idea of the net force. Net force. Net, the vector sum. So, we need something to have a force on it. So, let's take a look at a road with our little style. Oh, let's see here. Let's have a yield sign. And we need a car. Here we go. Oh, car's going this way. So let's have him moving at a nice constant velocity of 30 meters per second. And then it should be like that. And the velocity is moving that way. Or it's got really good reverse. If it's moving at a constant velocity, I better write that down, constant velocity, then all of the forces, the vector sum of the forces should all be the same. So what do we have? Well, we have air resistance pushing backwards. We have the force of the engine pushing forwards. Well, that's just in one dimension. What else do we have? We have gravity pulling down. We haven't talked about what that is yet. And we've got the road pushing up. The sum of all those forces, all the forces, have to equal 0 because it's moving at a constant velocity. If you don't remember, this is the Greek letter sigma, and it means sum because it's the first letter of the letter alphabet there. So now, a net force is required to change the object's state of motion at all times. So, if this is not changing its state of motion, then its sum of the forces that are on it are 0. But if I want to make it move, I'm going to need a net force. But some things are harder to push than others. This car's pretty easy, but this truck's going to be a whole lot harder to move. Why does this one so much harder to move than this one? Why does the change of velocity of that truck so much more than that car? Let's take a look. All right, let's push this one out of the way. Let's push this one out. Oh, it's just too hard. All right, this resistance to change. Resistance to change its state of motion. That's called inertia. All right. So, in the metric system, how do we measure this inertia? We measure the inertia through the amount of mass an object has. Mass is the amount of inertia. But wait, you say, isn't mass the amount of matter that's there? Doesn't mass equal matter? Well, what's matter? Well, isn't that the amount of, here, wait, amount of stuff? Well, what stuff? Are we talking atoms? Ooh. how many atoms you have. Alright, it's not to scale. Well, what about protons? Or neutrons? Or even electrons? If it's not an atom, it's going to be one of those. But what if it's not a proton, a neutron, or an electron? What if it's something else? Well, light doesn't have mass. That also means that light doesn't have inertia. Then what are we talking about when we say mass, this inertia? Well, as far as I can tell, this is what the Higgs field is for. What's that, you say? You want to know about the Higgs boson? The Higgs field predicts this thing called the Higgs boson, which then should give all things their mass. That's for another time, like way another time. So how do we measure amount of mass? We like to use the kilogram. Its abbreviation is kg, and it's measured by this thing that's in France. It's I think it's an iridium platinum bar chunk. Anyway, why don't we just use a gram as opposed to 1,000 grams? Well, in the physics use what's called the MKS system. That's the meter, the kilometer. Man, this is kind of hard to read. And the second. Why don't we use the CGS system, the centimeter gram second system? Well, because that's what chemists use. And I'd rather not use that kind of stuff. So, finally, what is the unit for mass in the English system? That's right, it's the slug. I've got these two out of my yard. What? It's not the pound? No, that comes in Newton's second law.